Let's start with Module 1. The tutorial starts by explaining the project architecture. When we ran ng new followed by the project name, that is recipe box, and selected our options like styling and whether we need server-side rendering or static site generation or SSG, the CLI created a standard project structure behind the scenes. A dedicated team of talented developers at Google had already done the heavy lifting of establishing a solid starting point that works as a foundation for any Angular application. This means we don't have to waste our time on setup and configuration. We can focus on what actually matters, building the business logic for our application. What I feel is that there was not much in terms of what the CLI does, and the AI tutor jumps straight towards running the command for getting the app up and running and proceeding with that, which makes the whole setup a mystery for an absolute beginner. So here goes my explanation for what Angular CLI does for us. The command line interface handles a ton of complex build process automatically. Let's start with something called HMR or Hot Module Reloading. It hosts the application on a local development server and instantly picks up any file changes, reflecting them in the browser in real time without full page refreshes. Point number 2 is bundling. It takes all the separate TypeScript files, components, and modules and intelligently bundles them into optimized chunk for the browser. The next point is transpilation. It converts our modern TypeScript and the latest JavaScript, ES 2015, 2016, 2017, whatever, down to ES 5 or whatever target we specify, ensuring compatibility across different browsers. The next point is minification and uglification. In production builds, it strips out the white space, shortens the variable names, and compresses the code to reduce file sizes dramatically. The next important point is tree shaking. It removes unused code from our local final bundle, so we only ship what is actually needed. Next point is code splitting. It automatically splits the application into smaller chunks that can be loaded on demand, improving the initial load times. Next point is build optimization. Behind the scenes, Angular CLI uses something called ES build and wait as of Angular 17 for lightning fast builds during the development. For production builds, it uses ES build combined with Angular's own optimizations. In earlier versions, it used Webpack, but the Angular team has been moving towards faster, more modern build tools. Next point is source maps. It generates source maps in development so we can debug our original TypeScript code in browser, not the transpiled JavaScript code. All of this complexity is abstracted away. We just run ng serve for development or ng build for production, and the CLI handles everything else. If you are new to Angular and feel a bit intimidated by the sheer number of files, don't worry. Let me break that down with what each file does. At the root level, we have angular.json. This file is the main configuration file for our Angular project. It defines the build options, file paths, and project settings. When it comes to .git ignore, this specifies the files that should be ignored by Git, like node modules which are meant for local development only. As a developer, we never touch the contents of node modules directly and make changes inside those. The .editor config ensures consistent coding styles across different editors and IDEs. If you are particular about spaces, tabs, etc., and need to ensure that the team follows those, this is the file to manage them. The package.json lists all the project dependencies and npm scripts that can be run from the command line. The package-locked.json locks down the exact versions of dependencies for consistent installs. The tsconfig.json is the main TypeScript configuration file for the project. tsconfig.app.json is the TypeScript configuration meant specifically for the application. The tsconfig.spec.json is a TypeScript configuration for test files or spec files. readme.md is a project documentation and setup instructions. When it comes to folders, the .gemini folder contains the configuration for Angular's AI features. The .vs code contains the IDE workspace settings. Node modules are auto-generated when we do npm install. It pulls down all the packages needed for the whole local setup to run properly. The public folder contains static assets that get copied as is to the output folder. The build process ignores any sort of optimizations to files placed within this folder. Usually favicons or fonts that needs to be served as is placed here. SRC is where all of our application code lives. Our life as a developer revolves inside this folder. The files inside SRC folder, it requires a bit more context for you to understand properly. Things like single page application, how it works, component tree, what exactly is a component, how do we define it, the concept of routing, bootstrapping, all needs to be explained for you to understand the big picture of how Angular does the bootstrapping behind the scenes and why we see what we see when we run the application. We will get to that a bit later. First things first, let's take baby steps. At least that is how I learned when I was learning Angular for the very first time. It was a lot to take, lot to digest and process. So if you feel exhausted or stressed out, definitely take a break and come back after a while. It's high time that we start something and get a feel of the AI tutor. So just to take a break from that and get our hands wet with Angular, let's try the project exercise mentioned by the AI tutor and make those changes and let the AI evaluate whether or not the task was done properly or not. Here the first task is the project exercise. Set up the main application title. The objective, your goal for this first step is to clean up the default content in the main application template and set a clear title for our smart recipe box application. The expected outcome is that when we are finished, the web preview should display a single H1 heading with the text My Recipe Box. So let's take this text from here. Let's move to the coding editor. Go to app.html. Clear the contents. Put an H1 and then paste our title. And to run the application, let's go to a different tab and do npm run start or npm start. This should start the application locally. Let's go to localhost 4200 and see if the application is getting up and running. Sure enough, we can see that the H1 with the title My Recipe Box is present, and to make sure that this is working fine, let's jump back to the Gemini terminal and then type here done. This will evaluate the code and tell us if we have done it right or not. It says excellent work, that's working perfectly. You have successfully cleaned up the template and set the main title for our smart recipe box application. Here is the point at which I disagree with the AI tutor. Mostly because it just asked us to change an HTML file and moved to the next module. Nothing was given as a context for us to understand how it worked and why are we seeing a header when the actual index.html does not contain any heading. It feels like magic because things just work like that. But in reality, nothing is magic. There is a lot of heavy lifting done by the CLI to get things done underneath. Without going too deep into the actual setup process, let me give you a high-level overview. The first thing to understand is the difference between a traditional website and a single-page application. Traditional websites work like this. You click a link, the browser requests a new HTML page from the server, the entire page reloads, and you see the new content. If you click another link, another full page reload. But Angular works differently. It's a single page application, which means there is literally just one HTML page. That's your index.html. When you navigate around, Angular doesn't reload the page. Instead, it swaps out components dynamically right there in the browser, giving you the feel of moving between pages. But it's all happening on that single page. This makes the app feel much faster and more responsive, like a native desktop application or a mobile application. That leads to the next question. How does Angular take that nearly empty index.html and turn it into a full-fledged application? To understand that, let's trace the journey. Angular.json is the blueprint of the application. When we run ng-serve, the CLI first looks at angular.json. This file tells the Angular, here is where your main entry point is. Here is where your styles are. Here is where everything should be built. In the main.ts, which is the ignition switch, the CLI then executes main.ts, which is the very first TypeScript file that runs. If you open that, you will see something like this. This line is bootstrapping or starting up your entire Angular application. Don't get confused with the CSS bootstrap framework. This and that are two entirely different things. This line tells Angular, hey, take this app component and make it the root of everything. In the index.html, which is the container, though it's mostly empty, there is one critical line, which is this one. This is a custom HTML element, which is nothing but a placeholder. Angular sees this and says, aha, this is where I need to inject my root component. In app.ts, which is the actual root component, we can see that within the configuration object, there is a selector property with the value of app-root. That selector app root tells Angular, whenever you see app-root in the HTML, replace it with my template. The app.html is the actual content. Angular then grabs the content from app.html, that's where our heading and other contents actually lives, and injects that into the app root placeholder in the index.html. To summarize the process in a nutshell, CLI runs main.ts. Main.ts bootstraps app component. Angular finds app root in index.html. Angular injects the content from app.html into the placeholder, and you see the heading. And all of this happens in milliseconds when the page loads. This is why it's called single page application. The index.html never changes. Angular just keeps swapping the content in and out of the placeholder dynamically. When you later add routing and navigate between the so-called pages, Angular will swap different components into this same container, all without ever reloading the browser. I hope that the concept of single page application is not magic to you anymore. Before moving towards module 2, one last important topic that needs to be discussed is components. So what exactly is a component? A component is the fundamental building block of Angular. The framework being in component-based architecture, basically what we build is just a hierarchy of components nested inside one another. At its core, a component is really just three things that we already know. HTML being the structure, which is what the users see. CSS being the styling, how it looks. and TypeScript being the logic, the business logic or how it behaves. That's it. HTML, CSS and JavaScript, the same web fundamentals we already know. In TypeScript, we have a concept called class that encapsulates properties and methods. A class, end of the day, is a blueprint for creating objects. That is the one-line interview answer that we already know for sure. When we use a class within a TypeScript file in Angular, there is nothing special about it, unless we add a decorator to it. The moment we add the @component decorator on top of that class and pass it a configuration object, that's when the magic happens. Angular looks at the decorator and says, aha, this is not just any class, this is a component. And here is what the configuration object looks like. This configuration has 3 key properties that we should know. The selector, which is basically the identifier for the component to be used elsewhere in the app, something like the app-root, template URL pointing to the HTML file, and style URL pointing to the CSS file. The TypeScript class itself contains all the logic, the variables, methods, event handlers, everything that makes the component interactive. The @component decorator is what transforms a plain TypeScript class into something Angular can recognize, manage, and inject into your application. Without it, Angular would just ignore the class. With it, Angular knows this is a component. It has a template, it has a style, and it has logic. I need to render this when I see its selector in the HTML. This is why components are called the building blocks of Angular. Every piece of UI we create is a component, and each component is a self-contained unit of HTML, CSS, and the logic working together. With that said, let's move to the next module where we discuss the concept of displaying dynamic data with interpolation.